start this bit. Okay, now when we talk about the pumps, we're going to have a look at hydraulic pump today. The pumps, the meaning of the pump is to convert the mechanical energy or the electrical energy that we get from mechanical into hydraulic energy. Now, any hydraulic system that's considered as a heart of the whole hydraulic system. Now, there are different types of pumps we use when we have a look. So when we classify the pump, when we have a look at the classification of pump, we have a look at non-positive displacement pumps. So non-positive displacement and then we got the positive displacement pumps. Now this is classification based on the displacement. And the other classification is based on the delivery. So classification based on delivery. Now the classification based on delivery is constant delivery pump. Or the other one is non-constant or variable. These are the two types of pumps, two main classifications. Then we got the classification based on the motion. The one that based on motion is rotary pumps. And the other one is reciprocating. Okay, now when we have a look at the non-positive displacement pumps, now non-positive displacement pumps, they are mostly velocity type pumps. And they have a clearance between the rotary and the stationary parts. So that's why we call it like a non-positive displacement pumps. Now I will show you the pictures of these pumps later. Now then we got the advantages and disadvantages of different types of pumps. Now when we talk about the advantages of non-positive displacement pump is they have less moving parts. So if I write down the advantages of this one. They have less moving parts. They have low maintenance cost. They are easy to maintain. They provide smooth flow. So the flow is smooth continuous flow. We can use all types of fluids. So they can handle all types of fluids, including the sludges and the slurries. The operation is simple to operate and reliable. Okay. Now, disadvantages are they have to be positioned below the liquid surface. They have low volumetric efficiency, so this is disadvantages. They have low volumetric efficiency. And the other one is discharge is related to the output flow. So the output resistance. So discharge is a function of output resistance. Now, this is advantages and disadvantages of the non-positive displacement. Now, if we have a look at the positive displacement, they have a very little slip. They are self-priming, and they can pump against a very high pressure. But the issue with that one is their volumetric capacity is low. Because they are the positive displacement, so they have a low clearance, very close clearance between the rotary and the stationary part. For every fixed revolution or rotation, they only transfer the fixed amount of the fluid into the system. I will upload the pictures of these pumps later as well, which you can actually have a look on your classrooms. Most of the pumps, they actually fall in the positive displacement. Now, when we talk about the positive displacement, they are actually characterized based on the type of motion of the pumping element. They are classified based on displacement characteristics, and they are classified based on type of pumping element. What are they pumping? Okay. Now, the examples for these ones are the rotary pumps and reciprocating pumps, the piston types. This is based on the pumping elements, characterization based on the pumping element. Now we got the displacement characteristics. These are fixed displacement pumps and these are variable displacement pumps on the positive displacement. Okay, now we have a look at the advantages and the disadvantages. Okay. So they operate at very high pressure. They can go up to like 800 bars. So that's extremely high pressure. They're used for lifting the oil from the oil well, all the way from the bottom. They can achieve very high volumetric efficiency. Okay. Now the other one is they are very efficient and their flow rate is constant throughout. So their efficiency remain constant. So if they are old, it doesn't mean they are not that efficient. They will follow the same until they are broken. They are quite compact. So power to mass ratio is high because of their compact size. So because they're so good, they can obtain us precisely and smooth and precise. Smooth and precise flow, or smooth and precise control motion. They can design, or they can actually program to transfer only the certain amount of fluid. You only want 10 liters of fluid. You can just program it just to transfer the 10 liter of fluid. So they can only transfer required amount of fluid. You can program that one. They are very versatile. They can be programmed over a range of pressure and range of speed. Range of pressure, range of speed. Okay. Then we got the classification of the positive displacement pump based on the delivery. We got a constant delivery pumps, we got the variable delivery pumps, and we got so we got constant delivery pumps, we got variable delivery pumps. So these are two different based on the delivery. Then we got the based on the motion. Classification based on the motion. Okay. Positive displacement, we done the positive displacement, we done the non-positive displacement. Yeah, okay. We got the rotary pump and reciprocating pumps. Now I'm just going to draw a picture and just rub this one. We talk about the. Now, if we have a look at the capacity, liquid per minute, like liters per minute, sorry, and the percentage. So this side is percentage. The centrifugal one, yeah. So it kind of, if you increase the capacity, its percentage efficiency kind of drops. Here, the capacity remains the same. Capacity is not increasing. Positive have the same capacity. If we have a look at the head and the velocity for centrifugal pump, If you increase the velocity, the head will decrease. For the positive, display positive pumps, if you increase the velocity, the head will increase. If we have a look at centrifugal pump, the head of the centrifugal pump and the percentage efficiency, let's say, it goes up, reach a certain value, and then it will decrease. For the positive pump, it's not going to increase. It just remains stationary. The head will increase. So if we talk about the positive displacement, the flow rate does not change with the head. The flow rate is not much affected by the viscosity of the fluid. And efficiency is almost constant with the head. This is positive displacement. If we talk about the non-positive, let's say centrifugal one, the flow rate decreases with the head, the flow rate decreases with the velocity, and the efficiency increases initially and then decreases. Efficiency increases initially and then it decreases. Okay, these things are known as performance curve. Now you will have a very similar one in your exam about the performance curve. Now then there are gear pumps. Gear pumps are the pumps that are less expensive, but they are limited to 140 bar pressure. The gear pumps are noisy to operate. And they transfer the same amount of the fluid for every RPM for same rotation. Then the gear pumps are classified into two: external gear pumps Now, the external gear pumps, I would put a document online so you can actually have a look. The advantages and disadvantages of the external gear pumps, I'm just going to write it down. Okay, they give constant delivery. They give constant delivery for a given speed. They are compact and light. Volumetric efficiency is high, and they are self-priming. I think there is single M, not double. Okay. When we have a look at the disadvantages, the liquid that we are going to pump should be clean. Can't pump like the slurries or the liquid with different particles. Variable speed drives is required to change the delivery speed. If you want to change the different delivery, more fluid, less fluid, more flow rate, less flow rate, we have to have the variable drive. Because they are self-priming, if they are dry, if they're running dry, it can cause damage. The reason it can cause damage is because the fluid that is pumping is also used as a lubricant. Because there is no fluid, there is no lubricant, and it can cause damage. Okay. Now the next bit is the equation for the flow rate.
And days to show them.
Oops. Yeah. Okay, expression for the theoretical flow rate of an external gear pump. Now, different variables, what are these? We have a look at these ones, and I will just write it down. So, D naught is the outer diameter of gear teeth. D I is the inner diameter of gear teeth. L is the width of a gear teeth. N is the speed of the pump. And the units are RPM. PD is the displacement of the pump. And the units are meters per rev. M is the module of the gear. Z is the number of gear teeth. Alpha is the pressure angle. Okay. Now, by using these ones, if I want you to find out the volume displacement, the volume displacement or displacement of the pump, the formula is given by volumetric displacement or volume displacement is given by Vd equals pi over 4 d naught minus di L. Now there's a square, d naught square and di square. If you want to find out the di, if the d outer diameter is given, you want to find out the inner diameter. Inner diameter is d naught minus 2 times the thickness. You can do that one. Now, if you want to find out the theoretical discharge, if you have a look at the theoretical discharge, QT, and the units are, let's say, meter cube per minute, it's given by this formula Vd, which is meter cube per rev, multiply that thing, the unit of this one is that, multiplied by n, how many revolution per minute, and the unit for this one is revolution per minute. So this is how we find out the theoretical.
What's the final unit for that?
Meter cube per minute. Now, here, there's a module thing, Now, what is that bit as well? If the gear is specified by the module and the number of the teeth, if that is given, then we got another formula. specified by module number and number of teeth on a gear. Then the formula, then theoretical discharge has a different formula. QT is equal to pi L m square n z plus 1 plus pi square cos square 20 cos square 20 or cos square alpha? Cos square 20. And that will give you the answer in meter cube per minute. Okay. Now we are going to have a look at one of the questions. And that's it. Let me just stop the video recording. Okay, let's say we got a question where you are given a gear pump has an outer diameter. So D outer is given as 80 millimeter. The inside diameter, which is DI, is given as 55 millimeter. The width, which is the L, so the width is given as 25 millimeter. The actual pump flow is, so the actual pump flow is given as 1600 RPM. So that is the value of the N. Okay. And the rated pressure, is 95 LPM. So the flow rate is given as 95 LPM. So the flow rate, I write it down as, I put the A as well. The flow rate is given as, actual flow rate is 95 LPM, liters per minute. Liters per minute, you can, and we imagine it's water. So we need to find out the volumetric. So the thing we need to find is the volumetric displacement. So volumetric displacement, and we also need to find out the theoretical discharge. Now this is the actual pump, so I call it QA. QT is going to be the theoretical one. So we got the width. If I want to find out the width, now I got the width already. Yeah. So we got the outer diameter as 80, inside diameter is 55. The width is 25. So now we can convert these ones, all these things, into meter. So QA is 95 LPM. 95 LPM is 95 times 10 to the minus 3 meters cube per minute. You can convert into meters cube per minute by multiplying it by 10 to the minus 3. So this is actual flow rate. Now you need to find me the VD, displacement of the pump. Displacement of the pump, we got the formula all the way up here. So we do the displacement of the pump. Displacement of the pump, let's use this formula. VD equals pi over 4 d naught square minus di square times by L. So pi over 4 d naught is 80. So that's going to be 80 times 10 to the minus 3. So that will be 0.08. And that one is 0.055. I'm converting that into meters. And L is 0.025. So put that in the calculator and you will have a value of the VD. Anyone got the value of the VD? $6.627
Yeah.
times 10 to the
-5.
minus 5. Okay. And the units are going to be meter per rev. Yeah, so these are units. Now, if we want to find out the theoretical flow rate, let's find out theoretical flow rate or theoretical discharge. We have a formula. QT equals pi over 4. Actually, easy formula. QT equals VD times by N. We already find out the VD. So whatever this value you got, the VD is 6.627 times 10 to the minus 5 multiplied by the N. Now what's the N? N is 1600. And if you put that in the formula, you will get an answer. Anyone got an answer?
0.11.
0.11. That will be, the units are always going to be meter cubes per minute. Yeah. So if you have a look at the actual, this is the actual flow rate. Yeah, which is, if you convert that one, it's going to be 0.095, yeah, meters cube per minute. And if you have a look at this is the actual one. If we have a look at the theoretical QT, theoretical is going to be 0.11 meters, 110 meter cubes per minute. So theoretical one is a little bit bigger than the other one. In theory, that's what it should do, but in real, it's not doing that one. The reason is because there might be air bubbles, there might be the non-uniform flow, there might be the gravity factor, there might be a lot of others inefficiencies, there might be the heat losses, the head losses, and all these things in the pump. So we don't consider that one when we do in theory, but in actual, there might be some issues. And hence we don't consider that one. But if they want you to find out what is the efficiency of this bit, you can work out the efficiency as well. Efficiency is 95 or actual divided by the theoretical multiplied by the 100%, and that will give you the efficiency of this bit. Now let's say if we got another question where we need to find out the theoretical density of the gear pump. The module of the gear teeth is 6 millimeters, that's given. The width, which is the L, is 25 millimeter. Make sure you convert these units into SI units. Number of the teeth, where is the number of the Z? Okay. The number of the gear teeth is given is 18. And the pressure angle, which is an alpha, is, let's say, is given as 20 degrees. The pump speed, which is an N, is also given as in RPM 1000 RPM. Volumetric efficiency. Now the volumetric efficiency, let me write efficiency, this is the symbol, and VOL. Volumetric efficiency is 90% or 0.9. We need to find out the QT. So the missing bit here is the QT. This QT is the one we need to locate. Now remember this, now we're going to use the complex formula. Yep. Okay. I think in the previous formula, I made a mistake. Instead of alpha, I put 20. But anyway, I'm just going to write the formula again. So I got QT equals 2 pi L m square n z plus 1 plus pi square cos alpha divided by 12. So just have a look at the other formula which I provided before. I just put like here 20, it's not 20. And I think it's pi square cos theta, it's not cos square. Okay, we check, we just put that one. Okay, if someone can put the value, 2 pi is the 2 pi. The L is 25, so that's going to be 0.025. The M is 0.006. N is 1000, so I'm just going to put that 1000 here. Multiply by 1000. And we have Z is 18. So that Z is 18 because number remain the same. 1 plus the pi square cos 20 divided by 12. And if you put that in your calculator, you will get an answer. Let me just pause that one. Okay. So that was a square here as well. So 0.006 square because that was the thing. And this n is here. So when you put that in calculator, you will get 0.1118 meters cubed per minute. So make sure you do like at least 4 decimal places in this case, because obviously it's 1000 liters in a meter cube. Okay, that's it for today. Going to